Hi everybody, welcome to Points of Topology and PTL Agency course. This is Shobik and I'm working across constantly matters. So this is the fifth lab session for this course. So in the last session we have done regarding things on connectedness, right? So in today's session we shall solve problems on connectedness. Okay. So yeah. Okay, so let's wait for a few minutes and or else we can start. Wait for a few minutes for students to join the session. Okay, so it is live session 5. Okay, so today we'll do problems of connectedness. Today, the problems on connectedness we'll do. Hi Rahul, can you please confirm whether I'm audible and is the screen visible to you?
Audible, sir.
Okay, thank you for confirmation. Okay, before starting the session, please let me know if you have any doubt or any question in the last session. Please let me know.
Sir. Sir, but in session we have saw the lecture video on matrixization.
Sorry. Which session are you talking about?
Sir, in the lecture video which I have taken which is taught by Professor Anand
Mm-hmm.
Sastri,
Yes.
they are teaching about the matrixization and compactification. But you are teaching the connectedness. I'm little confused about now.
Okay. Oh, but actually, connectedness is also in the syllabus. That is why I was teaching that. Okay, so you are you are basically asking to teach the metrization. So one you told metrization and what another you told
What, sir?
uh,
Compactification.
compactification. Okay, no problem. So today we can go with compactification. No problem for that. So can you please tell me how much he has covered or what are the topic he has covered?
Sir, till now, I have watched the video of week 4. So on Thursday, I have to submit the assignment of week 5. So today, I will take the lecture of week 5. And in week 5, I saw the compactification lecture, Stone-Weierstrass theorem. They are te- teaching us.
Hmm. Okay, understood point.
In week 4, they taught about the Alexandrov compactification proper map, stone compactification.
Understood that point. Okay, no problem. In that case, today we will start with compactness.
So, but in the in the third session, we do the se-
In
compactness
in
of the
third session,
topologicals.
in third session, what you have done
We have studied the compactness of the topological space.
in his
Uh,
lecture, right?
no, sir, you taught us in
Yes. Oh, right. Correct. Right. Okay, so in that case, we can proceed with one byte compactification and Stokes theorem, all these things.
sir.
Okay, so before starting further, let me know, do you have any doubt or any question on that?
No, sir. No doubt.
Okay, just hold a moment. Okay, so today we start with the compactness. Sorry, specifically a one-point quantification. Okay, so uh, first of all, what does it mean by compactification? So by the word compactification itself, it is clear that suppose if we have a space X that is not compact, I mean suppose we have a non-compact space, then is possible to compactify that space. Okay, that is called compactification. That means some space is not compact, then you do some operation on the space so that the space becomes compact. Okay, for example, open interval 0 1, leave it. For example, open interval 0, close interval 1. Okay, open interval 0, close interval 1, is it compact?
No, sir. On real line, it is not complex.
So since it is not compact, so we are adding a point 0, we are adding a point 0 here, so that it becomes close 0 comma close 1. Now close 0 comma 1 is a compact set, right, by Heine-Borel theorem. So
Yes.
this process of creating a compact space out of a non-compact space by adding 1 2 3 or adding few number of points is known as a compactification. Okay, is the intuition clear?
Sir, here we use a finite number of terms, or we may add infinite.
Yes, we can have infinite. For example, what? For example, what is going up? For example, mm, 1 minute. Let me think. For example, op open interval 0 1. It's disjoint union. That how it looks like. So open interval. This one is this. So there are infinitely infinitely copies of open interval 0 1. Okay, now we can, now the point is that if you tell that we each edge we add 1.011 in each edge, then you may say that it may look compact, but in that case after adding the 0.011 in the edges, we will get what? We will get close interval 0 open interval 1, right? And that is an unbounded set, so it is not compact. However, we can do this task in the following way. We have this 0 comma 1, this thing, this open interval 0 comma 1 is same as this, correct?
Yes, sir.
Yeah, so we will have infinitely many copies of things like this. Sorry, so we have infinitely many copies of things like this. Oh god, what is basically it looks like this. And infinitely many it comes, it goes to infinite many. Now if we add 1 point here and join this point to each of this portion, we will get what? We will get a shape like this, correct? Is the
Yes,
intuition clear to you?
yes, sir.
So basically, so that means what? We are adding 1 point, but still you are getting a compact set out of a non-compact one. Okay, and by the way, if you and 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 and, uh, and the example which you asked for infinitely many points, it can be seen as follows. We have open interval 0 1, right, and we remove infinitely many points so that it becomes 0 and 1, but in between there are infinitely many points got removed, and then if we add those points back in this place, then it will be open interval 0 close interval 0 1, so that will be compact. So that means compactification has nothing to do with the cardinality of how many points you are adding or subtracting. Is it clear? Compactification has only to do with how to compactify a non-compact space. Is it clear?
Sir, I have a doubt. If we took open interval 0, comma 1 intersection with Q,
Mhm.
and we are adding the in Q complement
Open interval 0 comma 1 intersection.
intersection with Q.
Okay.
This is non-compact set, and we add all the Q complements elements of 0 comma 1, so we can make it compact
Yes, because whole thing we are you taking union of q complement, so it will be
intersection with
close
0.
0 comma 1, right?
Okay, sir.
Yeah, so it will compact. So this is what compactification is. That means a way of how to compact non-compact spaces. That's all. Now, the next thing is one-point compactification. So the thing is, one-point compactification by name you understood probably that that means the space can be made compact by adding one point to the space. Suppose that means open interval 0 and 1 we have, we cannot add 2.0 comma 1. Such a thing that is not allowed under one point compactification. What is allowed? We have an open interval 0 comma 1. This is same as this thing, right? Circle minus a point, and here we are adding 1 point extra, we are adding 1 point, so it becomes a circle s1. So one point compactification means we must add 1 point to the space to make it compact.
But sir, here in circle we make we add 1 point, so we make it complete circle. But in the real line, it is not compact.
Huh? No, sorry, sir, repeat again.
I- As you mentioned, we made a circle of 0 comma 1, and we adding a 1 point, so it complete form a circle.
Hmm.
But in the real line, 0 comma 1,
Hmm.
either we add 0 or add 1. So here we can't get a compact set.
Exactly. So adding in this way does not allow to add 1 point to compact, but in this way, adding one, allowing us to add 1 point to make it compact. That is the only difference. Clear?
Okay, sir.
Yeah. Okay. Now, so this is the intuition. Okay. Now the definition is as follows. So in mathematics, we must have definition. Intuition not work. So the definition of one-point compactification is as follows. So let X be a locally compact. I will explain the terms. Let X be a locally compact Hausdorff space. No, sorry. The definition is Okay, so before that there is a definition of locally compact that must be said. So the definition locally compact, as you probably guess from the name itself. So this talks about compactness locally. That means what? That means if you have any space X, if you take any point little x inside X, and then you will get some local neighborhood U of X which is compact. Okay, that is what locally compact. That means locally if you take any point X, around that X you can get an open neighborhood which is compact. So that is what local compactness means. And definition is as follows: a space X is said to be locally compact at X if there exists a compact subspace U. The compact subspace which contains a neighborhood of X. A space is said to be locally compact at X if there is a compact subspace which contains a neighborhood of X. Is the definition clear? Let me know. Is the definition clear or not? Let me know.
Sir, here we get a compact subspace of X.
Compact subspace of X. Yes, yes. I mean, of course, we have X as bigger space, so everything else is a subspace, right?
No, no, no. Here we are talking about the space, small x, the neighborhood contained in the subset of X, capital X.
Yes. Yes, yes. I mean, the definition saying that suppose we have a capital X as a big space and little x is a point, then it will be said to be compact if capital S contains a compact subspace which contains a neighborhood of little x.
Okay, sir.
Yeah. So is the definition clear?
Yes, sir.
So tell me that whether real line is compact or not. Sorry, real line is locally compact or not. Is real line locally compact or not?
Yes, sir.
Why?
Because every point of real line on real line we have a compact subspace.
What is the subspace? That is the question. Tell me the subspace.
We took the a point X on which belongs to R, so we can get epsilon distance X minus epsilon closed interval 2X plus epsilon. We can take this subspace.
Okay. What about R square?
R square. We
Yes.
get the open ball. Oh, sorry, closed ball.
Okay. So that means is it true or false that product of any two locally compact space not necessarily locally compact? Is it true or false? Product of any two locally compact space is not necessarily locally compact. Is it true or false? Is it
False, sir.
okay? Why?
Sir, because we get the open neighborhood and closed neighborhood of every point.
Correct. Okay. So this question that I've asked you is the product of two spaces. What about if we take countable product? Then is it true or false? That means countable
Co-
product of
R,
locally compact space is compact or not. Countable infinite product.
sir, locally compact, same.
Yes, countable infinite product or locally compact space is compact or not.
Compact, sir.
Why?
Sir, there we also get the open ball.
That is okay, but why the product of compact subsets which we will get from each xi will be compact? Is the question clear? What I'm basically
Yes, sir.
asking?
Yes, sir.
Yes, so tell me why the product of compact set will be again compact.
Sir, because in each of the space, they all are compact. We get the compact subspace which contain a neighborhood of X.
I understand each xi contains a compact subspace, call it Ci, right? So the question is why the product of Ci is compact? Is the question clear? Why product of Ci is compact?
So by definition,
How?
so,
Yes, tell me how.
so what you tell the question?
Why product of compact space is compact?
Product of compact space is
Yes, not just finite product. You told me the arbitrary product. So why the arbitrary product of compact space is compact? Arbitrary countable product. That means C1 cross C2 cross C3 dot dot dot. Why it will be compact? Even that each Ci is compact. Explain. Or okay, think about it. Think about it. Any idea what it is?
no, sir.
The point is that it is something called Tikhonov's theorem, and this will be taught at the end of this course. Okay. So this particular theorem tells that arbitrary product of compact space is compact. Arbitrary product of compact space is compact. Okay.
Okay, sir.
So for the time being, don't go to the proof. it will be a waste of time. You take the theorem, read the Stegner theorem, remember the theorem, and apply it for solving exercise. That's all. Don't go through the proofs. Okay. Okay, so yeah, that's the thing. So tell me one thing that so next question is, suppose x and y are spaces such that x cross y is locally compact, then is x and y are compact. So this question tells that x and y in spaces such that the product is locally compact. So the question asking that whether x and y are separately compact or not. Sorry, separately locally compact, not compact. Sorry, it should be locally compact. Sorry. Okay. So tell me whether x and y are locally compact.
Sir, no, sir.
Okay, why?
Sir, because we took the x cross y is r cross z.
Okay, 1 minute. So you are taking x to be real line and y to be the set of integers, is it?
Yes, sir. And
And
x
then
cross y, all the mm, vertical lines.
x cross y is all vertical.
Vertical or horizontal
It will
line?
be y will be zero. It will be horizontal line.
Yes, sir. All the horizontal line.
Yeah, okay.
Then here every point is locally compact.
Every point is locally compact. Correct only.
But z is not compact, locally compact.
But why z is not locally compact? Because z means what? Union of singleton points, right? And each singleton point is compact set itself. I mean, the topology on z becomes a discrete topology, right? So every point becomes open set, and singleton set is anyway compact, right? So z is anyway locally compact, correct? Are you understanding why you have done the mistake? See, z is, I mean, r is not compact, that is correct, but r is locally compact. Z is
Yes, sir.
not compact, that is correct, but Z is also locally compact because singleton points are anyway open set in Z, and anyway singleton set is compact, so there is nothing goes wrong here. Is it clear?
Okay, sir.
Yeah, so think about it. Take your time, think about it. is are you able to figure out? Any guess or an idea?
No, sir.
Okay, first of all, the answer is true. Okay, but you have to prove that. So for that, what is the obvious way? I mean, it's not obvious first of all. Sorry. So we have a projection map from x cross y to x, the first coordinate projection, right? Correct. Now
Yes, sir.
try to use this map and try to use the properties of this map. Okay, let's try. So first tell me, okay, plus first you try, then I will explain if not. Try to analyze the properties of this map. Okay. Take your time. Are you able to figure out?
Sir, I thought about this. We took the ball of x cross y to the single uh, line on x minus epsilon to x plus epsilon.
Okay then.
So here we get a compact space of x.
Okay then.
So x is locally compact.
Now, first of all, so you are using the fact that x cross y is locally compact, is it?
Yes, sir.
Okay, by the way, so okay, that's good. But the first thing, the wrong which you have told is that x, I mean, open set of x plus open set of y. That means elements of the form u cross v is of course an open set in x cross y. That is correct. However, it does not necessarily mean that any open set of x cross y is of the form u cross v. That is not true. So you take any point x cross y, we will get a compact set of that point x little x cross y containing an open neighborhood of that point little x cross y. But it does not mean that their open neighborhood is of the form u cross v. Is it clear?
So how can you say it doesn't due to the continuity of the map?
No, what I one minute. One. So for example, consider R2. Why it is not coming? One minute. Hold on. For example, consider R2. Okay. In R2, this is an open disk. Correct? This open disk is an open set. I mean, come on. I mean, it's open disk, right? So it's an open set, right? Correct? It's open disk.
Yes.
But it is not of the form u cross v, correct? Because elements of the form u cross v shall always look like a rectangle.
Yes, sir.
So that means open. It's not. It is not a form u cross v, right? Correct. Is
Yes,
it
sir.
clear? So that means elements of x cross y not always be said as the form of u cross v. So
Yes.
directly you cannot use that. Try to use the properties of the function pi1. Okay, there are two properties of pi1. Pi1 is continuous and pi1 is open. Now try to use this property to prove that try to use this property to prove that x is locally compact. Okay, don't go to proof of these properties. Use this property and first try to show that x is locally compact. Okay, is it clear? So please try. So there is one student joined. So currently the problem which we are discussing is as follows. So the problem reads as follows. Suppose x and y are two spaces such that x cross y is locally compact, then show that x and y are locally compact each. Okay. For that, the method which I asked him to do is that there is a function called pi1 which is a projection of first coordinate, and the properties of the function pi1 is continuous, pi1 is open. I'm going to now try to use these properties to show that x is locally compact. Okay. Take your time, think about it, let me know. Are you able to figure out how to approach this?
No, sir.
Yeah, yes or no? Yeah, I'm not able to listen properly. Yes or no?
No, sir.
Okay, so let me explain. So the thing is, one the thing is as follows. See, pi one. What? Huh. So, so we need to show that what we need to show that one. So we need to show that x is locally compact, right? So what we'll do? Choose x belongs to x and choose some y belongs to y. So the point x comma y belongs to x cross y. Correct. Now x cross y, it is locally compact. So that means there exists a compact subspace C inside x cross y such that C contains an open neighborhood W inside x cross y. Up to this much clear?
Yes, sir.
Okay. Now apply pi 1. So pi 1 of C contains pi 1 of W, and this contained little x, and this pi 1 of x cross pi 1 of W, it's an open in x. So first of all, pi 1 of C, this is compact. Y, C is compact. Y, pi 1 of C is compact.
As pi 1 is continuous now.
Correct. And W is open. So pi 1 W is open because pi 1 is open. So that means a compact set contain an open set, which is open neighborhood of little x. So that means what? That means x is locally compact. Is the argument clear to you?
Yes, sir.
So what about y? Is y locally compact?
Yes, sir.
Now tell me, suppose. Now tell me, suppose uh, countable infinite product x1, x2, dot xn. This countable infinite product is locally compact. Then is each xi locally compact? Tell me. Is xi locally compact?
Yes, sir.
Why?
By doing the above steps, same.
Okay, got it. Correct. Okay. Okay. So now, okay. So is there any more properties? Okay, there is no properties. Now there is a theorem, and that this theorem is basically one per simplification. So the theorem tells that don't go to the proof of the theorem, just statement is enough. So theorem tells that X is a space, then X is compact, sorry, X is locally compact Hausdorff. If and only if and only if there exists a space Y such that Y contains X, Y is compact Hausdorff, then Y minus X is 1. So the statement says that X is a space which is locally compact Hausdorff if and only if there exists a space Y such that Y contains X, Y is compact Hausdorff, and Y minus X is equal to 1. So is the statement clear? Is the statement clear?
Sir, can you explain the line to statement to why
Ah,
is
Y is compact Hausdorff, compact as well as Hausdorff.
okay, sir.
So such a Y, what is such a Y? Such Y is called one point compactification of X and denoted by X to the power infinity. Such a space Y is called a one point compactification of X, and we is denoted by X to the power infinity. And it is unique up to homotopy equivalence. Sorry, it is unique up to homeomorphism.
Sir, screen scroll down, please.
Oh, is it fine?
Okay, sir. Now I have to. Okay, sir. Done.
Okay. Okay. So is the statement clear or not? Let me. Is the statement clear or not? Go through the
Okay, sir.
statement. Yeah. Okay. So okay. So first of all, your question will be how the Y is come. I mean, what is Y? The thing is, Y is some space. For the time being, you just keep in mind that such a Y always exists, and it is known as the Warburg amplification. For the time being, you may ignore the proof. because this proof will not be asked in university exam, not in. And by the way, are you planning to sit for write the NET or GATE exam?
Yes, sir.
So there also you have some problems will come. No question, no nothing to prove there. So that is why first let prove few small problems regarding this one point quantification, because the definition itself is extremely abstract. Okay, so proving, I mean solving problems is important for this portion. So the obvious task is mathematically show that, I mean you have to prove that one point compactification prove that one point compact what happens, one point compactification open 0 closed 1, it is closed interval 0 comma 1, prove it. Don't, I mean initially whatever the argument we see, that's an intuition, there's no problem, but mathematically how to show that open 0 closed 1, its one point compactification is 0 1. That means what we need to show, I mean what we need to do, that means to show that,
So could you
I
please
mean,
change the color pen
oh,
color?
sorry, sorry. Now fine. Okay.
Yeah, okay, sir.
So, okay. So now can you please show that closed, I mean, open interval 0 comma infinity is equal to closed 0 1.
So it is the infinite product of open 0 1.
Oh, sorry. What product?
Open 0 closed 1 to power infinity is the infinite product.
No, 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 no. That's what I explained now. So such a y is for one point quantification of x, and it is denoted by x to the power infinity.
Oh, okay, sir.
So that means 0 1 is to power infinity, means it is denotes the one point quantification of open 0 closed 1. So why it will be closed 0 comma 1?
So because we get take y is close 0 to 1 and y minus x is cardinality 1.
Correct. So yeah, it's direct. So there is nothing much to do. Absolutely correct. Now the next question is open 0 1. Its one point quantification is a circle S1. So try to prove it. Open 0 1 is one point quantification is circle. That means what? That means you need to construct a continuous function h from 0 1 to s1 such that h of 0 1 equal to s1 minus a single point. So first, is it clear to you that why such an h is required to solve this problem?
Yes, sir.
Okay, now construct such a function h from 0 1 to s1 having that property. Try to figure this out. So are you able to figure out construct such a function?
Can we use a trigonometric function?
Yes, yes, you can use anything. It has to be continuous, and that's all. Anything can be used. So what is the function?
Sir, as I thought in the complex analysis, stenographic projection, maybe it's like cos 2 theta, cos 2 theta plus I sin 2 theta.
It means t going to cos t comma sin t, right? So
Yes,
see,
sir.
so this is not a trivial position. This is exponential map. It's exponential map. And stereographic projection is a map from
Sphere to
S1
plane.
minus a point to full real line. That is stereographic projection. Okay.
Yes.
So anyway, so this exponential e to the right t. So this map satisfies this given property that h of 0 1 is equal to S1 minus S point. So this solves the problem. So now tell me that uh, so that so that rationals, set of rationals are not locally compact. So that set of rationals are not locally compact. So try to show this, try to do this by yourself. Is the question clear?
Yes, sir.
So think about it, take your time.
Sir,
Yeah, please continue.
sir, as we know, every neighborhood of Q at that at point X we contain rational and irrational both point, and we know the only compact space is singleton set in Q. So here we not get any subspace of Q which is compact, only the singleton set.
Uh, okay. Mm, okay, repeat the argument again.
Sir, as we took the element x from the rationals,
Yes.
if we took the neighborhood of that point, we get rational and irrational both. But here we need the a compact subspace of Q. But the only compact subspace we get the singleton set X. But in neighborhood of X contain both rational and irrational, so we cannot get the locally compact space.
So no sooner you are saying that neighborhood of X contains both U, sorry, I mean neighborhood of X, and you are, when your top space is Q only, right? So neighborhood of X means U intersection Q you have to consider, right? I mean you need to, I mean you are considering the Southwest topology, right? So their neighborhood means you have to consider the neighborhood of the neighborhood U intersection Q, correct,
Okay.
right? Is it clear that what is the problem in this argument?
Yes.
Yeah, so yeah, think about it. And the next argument, what you told, that compact set are Q, I mean singleton. So that seems to be correct. But for the open set, you have to consider U intersection Q. I mean, U is an open set inside Q. You are no, you use not an open set inside R. You are considering open set inside Q, that is capital U. So that contains only elements of Q, right? So it has nothing to do with irrational. I mean, this lies entirely inside Q. Okay, think about it.
Sir,
Yeah, please tell me. Yeah, tell me. Oh, sorry. Yeah, tell me.
Said as the neighborhood of x, as every neighborhood of x,
Hmm.
it's compact, it's singleton set, and in Q we get a neighborhood Q intersection Q, which is which is not contained in the small x, which is compact only.
Why?
So because the locally compactness, there exists a compact subspace which contain a neighborhood of x. So here we are not getting any space which contain the neighborhood of x.
Why such a C cannot exist?
Because the only compact space is singleton.
Correct. Right. Correct. Correct. Absolutely. Very good. Very good. Okay. So the next problem is, so that the consider the positive integers, so that its 1 point compactification is equal to the set n belongs to n1 by n union. Is the question clear?
Yes, sir.
So set consider set of positive integers is 1 point compactification is 1 by n belongs to n. So that's it. So try to show that. Are you able to figure out?
Sir, here we took a map hx
Yes.
which tends to 1 by x where x not equal to 0, and we took the y as
Hx equal to 1 by x when x not equal to 0 and
x 0 when x equal to 0.
so tell me first from where the function is from where to where?
Z plus 2.
This set call it x. Okay.
Yes,
So you're defining x into 1 by x, right?
yes.
So from where extra element is coming, you are saying. So the extra element 0 from where it is coming.
What's that?
You just told there are one element x equal to 0. You will take x equal to 0. You will take put equal to thing that h equal to 0 when x equal to 0. From where this 0 thing is coming. Hmm? So you told that whenever x equal to 0, it will be 0. So from where that is coming?
So can we reverse the map x to z plus?
No, no, no. We cannot reverse the map. So we need to show z plus is this one, right?
Yes.
So we cannot reverse it. So we had to construct a map h from where to where? From z plus to x. Only one direction. Reverse direction is not the. I mean, we cannot do the reverse direction, right?
Okay, sir.
Okay. So the next problem. So next question is that.
Sir, in this problem, how we defined the map is the same. Yes.
Yes, n goes to 1 by n.
And what about 0, sir, as you asked me?
See, so first of all, it was the set of positive integers. The question was on set of positive integers, right? The set of
Yes, sir.
positive integers 0 does not exist, right?
Yes.
So I mean, so there is no 0 in the picture, right?
Okay, sir.
Hmm. Okay. So so the next question is suppose x sorry suppose x be locally compact and if x to y be continuous. Question is f of x locally compact? We have seen that continuous image of compact set is compact, continuous image of connected set is connected. So the question is continuous image of locally compact is locally compact or not. Okay, is the question clear?
Yes, sir.
Yeah, let's try to figure this out.
So,
Yeah, Taufik.
and there exists as X is locally compact, then there exists a C which is compact subspace of X. So, and if is continuous, then f of C is compact also.
Yes,
So there exists a point X belongs to C. So f of X belongs to f of C.
yes.
So there exists f of X is locally compact.
What about the open thing? I mean, compact set must contain a open set, right? Wow. What is that open set? You told the F is the compact. Understand? What about the open set? What is the open set you are getting?
We need to find the open neighborhood of X.
Yeah. So what is? I mean, yeah. That's what I'm asking. What is the open number? Is the question clear?
Yes, sir.
Yeah. So think about it.
Sir,
Yeah. Tell
sir, and X we took the open neighborhood of X U, which is which is contained inside the compact subspace of compact subspace C of X. So as the compactness f of u, f is continuous, so f of u tends to f of u.
you're saying. I mean, if it's continuous, that's okay then.
So open neighborhood of x u, which goes to f of u,
So f of u. Why f of u is open? I mean, f of c is compact. Understand? But why f of u is open?
because u is open and f is continuous, so f of u is
But
open.
I mean, if it's continuous map not necessarily an open map, right? Correct?
Okay, sir.
Yeah, I mean, point is make concepts clear. I mean, then read from easy books. From where are you reading this topology thing?
I'm just watching a video and reading the mankars.
Grace, okay. Reading Grace, okay.
And I have also a book, Topology of Metric Spaces from our sensor.
That Kumaresan matrix specifically you're talking
Yes,
about,
sir.
right? Okay, that book is good anyway. Also very good book. Yeah, Mankar is also good book. But in that case, please try to solve problems by yourself. I mean, do you solve problems or just reading only?
So, which is easier? I just wrote the which are difficult. I just googled it, and after some time I forget.
then it is, I mean, just Google it. If you forget that, then of course in exam also you cannot write. I mean, it's not about mugging up things, it's all about understanding the what is the problem, right? It's a basic definition. See, the f is continuous map, so it is continuous, not necessarily open map. So open set not necessarily good open map, it's something you cannot mug up. You have to keep this thing in your mind always, right? So these are small things. Solve small problems, but solve problems for solve many problems, because subjects, this particular subject is extremely abstract. Okay, so people will forget, there is no problem, but you have to practice it. Without practicing, it is extremely difficult, this subject, to be honest. Because in exam also the questions are easy. I mean, in competitive exam I'm talking about, the net gate, or yeah, net and gate at the exams mostly. So there the questions are not difficult, but you have to practice in order to access problems, right? Without practicing, it is very difficult, and make the concepts clear. Okay, I don't know whether though that whether those lecture videos are useful or not, but the point is you should solve at least 5 to 6 problems each day. Otherwise, it is difficult to remember this type of abstract things. Okay, that's a real problem. Yeah. So just tell me one thing. Just so you want to do PhD, is it, or you want to do after net you go to some other direction? What direction you want to go?
I want to. I wanted to think PhD.
Okay, okay, got it. PhD is what? I mean, which subject you are interested about?
As the professor taught me the topology, I was quite curious
Who
about the things. But
who taught you topology?
uh, there is a who was in the college. They are just finished the PhD and they're
Okay.
teaching us. So they taught me the topology. That time I was too much curious.
Well,
But after
that's
that, our HOD taught functional analysis. Then I'm curious about the functional analysis.
see, the point is, I mean, I understand. Whatever you think is correct. There is no wrong about it. But while choosing subject, remember, listen carefully. While choosing subject, you have to be very careful, because different subject has different kind of rate of acceptance. For example, I mean, do you know the fact that in PhD you have to publish paper? You know that, right? Correct.
Yes, yes, sir.
And also, I don't know whether you know this or not. There is something called turn around time of some paper. That means you submit a paper, it may be accepted, it may be rejected. But the problem is, there are certain subjects in which this time is, I mean, suppose some paper got rejected. If it get rejected immediately, then it is fine. But if it get rejected after 6 or 7 months, then it is a waste of time, right? Correct.
Yes.
And there are many subjects, specifically pure mathematics, there are many subjects which has this problem. Okay, so while choosing subject, please do consider this kind of thing, otherwise it will be a very big problem. And not only PhD, after PhD you have to do postdoc, then you have to get job, right? So it will, yeah, it is a lifelong problem otherwise. Okay, so that is why choosing subject is extremely important. Difficult, of course, but it's important to take that subject which you want to choose. Okay, that is the first thing. And second thing is that, the point is that, listen carefully, the point is that always try to take those subject in your PhD which has some kind of industrial application. That means those subjects which are useful outside academia. Okay, otherwise your job, not only, I'm not talking you only, I mean, I'm not pinpointing you, otherwise only pure subject has extremely low job opportunity. Okay, I'm pretty sure that you have seen, I'm pretty sure that you have some of your seniors who are doing postdoc, is it?
Yes, sir.
Yeah, the point is, okay, so first, can you tell me the most of the postdoc are from which background, pure or applied?
Sir, I only know two people who is doing postdoc. One is my neighbor who is postdoc in Slovakia. They are doing the combinatorial topology,
Okay.
and one is in the my senior college who is doing IIT Kharagpur in I don't know they are
I am audible.
yes sir
Okay, sorry for so there is some issue with my laptop. Okay. So basically the point is that you should always consider those subjects of PhD which has some kind of application outside of academia. Okay. And it's a big thing because more in I mean if you see around or if you get mature a little bit, which will take time to understand the reality, you will see that generally it turns out that uh, if you see that some people are doing postdoc, then most probably most probably the people is not getting job in that area of research. Okay, and it's a big problem. It is not just a problem; it is a very big problem. So you might not have those kind of seniors who have finished postdoc but still unable to get a job. But in pure mathematics direction, this kind of thing are very common. Okay, so you still have that opportunity to choose a subject very wisely. So do take this decision very wisely. Okay, and that is the first thing. And the second thing is that I mean, yeah, there's a thing that you have to choose subject very wisely. Otherwise, it will be very difficult. It's not about only PhD. After PhD, there are many many things to do, right? It's all about publication, or it's all about collaboration, all these things. Otherwise, it is extremely difficult. Okay.
sir
Yeah.
I have I studied the in optimization theory so I'm thinking to go through the optimization but the problem is that my professor gave a project in complementarity problem which is lie in the optimization theory so now these days I am reading these complementarity problem because I have to do project in this but that was they told me to read all by yourself do everything all by yourself whatever you
So
have done
combinatorial problem
just
means you are saying the problem is from combinatorial topology, is it?
no complementarity problem which is lie inside the optimization theory
Okay, okay, understand the point. Understand the point. So,
yes sir.
okay. So as per my understanding, that has little bit good job opportunity rather than topological algebra. Okay.
So, but I have seen the many as the I have seen the many professors biodata resume CV. There are only two or three professors I have seen here in मतलब top IITs. They are doing in this field, but other I have seen the most of them are
This optimization field, is it?
yes, optimization no, no, there is some people which are we are doing in optimization, but not in the complementarity problem.
I understand.
So
Understand. So I mean, so the thing which you are talking about is, I mean, does that have any kind of real life application?
yes, they have real life applications such as traffic equilibrium problem, and
No, no, sorry. Real life application means I'm talking industry application.
yes, the traffic is the real valued application. They are just about talk about the goods supply in the mm, production market. So how to manage a good connection between those that are the talking about the traffic problem.
So that is it true that if you do PhD in this subject, then apart from academia, you have the option to go to some industry also. Is it true?
I didn't explore about this.
Yes, yes.
I
Please
have to
explore.
explore.
Yes, yes. Please explore because after you join PhD, it is not possible to explore because after joining PhD, you have to fix kite. Changing those things are very difficult, right? So you have to explore these things first. Okay. I mean, if you the point is very simply, if there is no job opportunity, there is no point of doing anything, right? I mean, that's the philosophy. You simply can't escape that.
Yes, sir.
So, and it is a big problem. So you have to explore that what are the opportunities apart from academia, because what is the problem in academia, because not every year government is establishing college universities, right? College university number is fixed, and a faculty can a faculty job is up to age of 75 70 years, I guess. So that means the number of seat will going to diminish day by day, okay, but number of candidates is getting increased each and every semester. So
Yes.
getting job in academia is extremely difficult. I'm not saying impossible, but what I'm saying, it is difficult. It is unnecessarily getting difficult. It is unnecessarily difficult without any extra reason. Okay. So
Yes.
that's why it's a problem. So that is why you should always keep in mind that you must have option apart from academia. Okay. Because in academia the growth is very fast. Firstly, secondly, that there is no job scarcity. Okay. Thirdly is that you can take decision on different things which in academics is not possible, and the process in academy is also very slow. So these are problems in academy. Okay. So that is why you always think, I mean, don't think like you like topology or you like algebra, go research. No, it's a waste of time. It may be, it doesn't matter whether you like or not. So, I mean, sorry, it sounds harsh, but the point is it really doesn't matter whether you something, whether you like something or not. At the end of the day, you have to have 5 6 papers in your PhD. The problem in topology is that, see, the topology is a very big subject, right? I'm not demotivating you, but the problem, the reality is topology is a very long subject, right? If you want to do research topology, you have to do algebra topology, and there are many things. It's very long, okay. Now the problem is that, suppose you have some friends, definitely a friend who, suppose somebody is interested in linear algebra, okay. Now, linear
Yes.
algebra people start in from graduation onwards. People started learning the subject. So, on the linear algebra thing, people can start research on the secondary itself. But in topology, people have to really study for 3 4 5 years. Then only people can start research. But by the time you reach fifth year, your PhD is officially ended, right? So, but
Yes.
then you have to produce papers also. But the your friend who took linear algebra, he or she might have produced 4 papers in 4 years, but you may have produced one paper in your PhD. That is not your fault. That the subject is like that. But it is a that's a drawback, because since you have one paper, so you will not get postdoc anywhere easily because you have only one paper, right? Now the problem is that, for suppose you do postdoc after PhD, you get postdoc, all these things. Now come back to job. In job, there is a thing called weightage of each paper. That means, suppose you have 5 papers, okay, each paper get weightage of 5 marks, okay. So that means, suppose you have 3 papers in PhD plus postdoc, so you get now weightage 15 for the total papers. But some of your friends had, for example, linear algebra. Suppose the friend who took linear algebra, he has 6 papers, so 6 into 5 30. So he always so he always win the race. So you, but it is very difficult for you then, right? That is why choosing a subject is extremely important task, because it's not only the subject you like or not, it's all about fastness also, right? So it's a big problem otherwise. I mean, it will be extremely problematic for you later on. You may not feel that is a problem right now, later on it will be a problem, because the point is, number how many papers you have, that has certain weightage. Suppose each paper have 5 weightage. uh, then there is something called uh, journal research factor, okay. Suppose there is some paper called on linear algebra, which is published in a very good journal, okay, and just that journal has good impact factor. Then that journal impact factor, if it is greater than 1, the person will get additional 2 marks. But if your journal has impact factor less than 1, you will get point half marks extra. Now this thing is not anybody's hand. That is why the subject or areas which has most students, faculties involved, those has generally good journal index factor. So those small extra marks will add up for getting job or for getting any other small things also, okay. That is why choosing subject is extremely important. Don't take it lightly. I mean, your faculty is telling something, okay, that is one thing, but reality is quite different. That's what I'm telling, because I am now going to I have now entered fifth year, so I understood the reality very clearly. That is what I'm telling you. Okay. And it is not me only. I understood that most of the pure mathematics has same kind of problem. So this is the problem. It's a real problem. People don't tell it other way. That is the real problem. I don't know why people don't bother about this problem, but it's a problem. Okay. So that's what I want to tell.
So in college, professor always talk about mm, there are more much subjects which are difficult. They don't even get a PhD in
But
six to
how
7.
does this matter? So my simple question to you is that, are you want to be Gyani Vyakti, or are you want to get a job first? Which one is important for you? Tell me.
It is important to get a job
Yes. So
because
in
the age is
yes,
increasing.
correct. So that means you have to work accordingly, right? There are many subjects which is very difficult. For example, our HOD, sorry, not our HOD, it is one of the physics department HOD who came and told a student not to do research on quantum physics. There is some quantum, there is extremely complicated something. But the point is, yeah, I mean, he's practical, there's no doubt about it. But the point is that, see, for in order to get a job, whatever the necessary task you have to do, just do it. It doesn't matter whether something is easy or difficult. It really doesn't matter. What matters in PhD is that how many papers you are able to publish. It's simple as that. How many papers you are able to publish. That's all. So in each year, if you are able to publish at least one paper, so after 5 years, you will have 5 into 4, 20 marks. Okay. Now the point is that if your paper is a single author, then only you will get 5 number in each paper. But of course, if you working with your guide, some of your paper will have name on of your guide, maybe some other collaborator also. In that case, you will get 2 marks or 3 marks in your paper. So that is why number of papers is extremely important. You cannot ignore that. Okay, and this is why the subject which has many number of students and faculties and researchers are important to choose those subject as your PhD and postdoc and also. Okay, but it's just pointless to see that some subject is so difficult to do PhD, but it's pointless for it's totally pointless. You have to do PhD in a subject so that you can get job easily, you can take good postdoc easily, you can get promotions easily, right? That is the target. I mean, not gaining knowledge without achieving anything is pointless, right? At least for me.
Yes.
So that is the thing. So yeah, that's a problem. I mean, that's a reality in India. I mean, I cannot do anything. I'm just telling you because you are an MSc, and so you have the option to think, decide, figure out. So that's the thing. Okay. So always try to figure out those, try to take those subjects which are some interest applications, and it is all, so it will be always better actually. So I don't know whether it's possible for you or not. You may explore the applied direction of mathematics, because in applied direction, as per my few of my friends working, many of them got job just after finished PhD. Okay, while the uh, first seniors who took pure mathematics, they are doing postdoc. Then after postdoc, they are doing struggling and blah blah blah. It is never ending loop. It is not their fault. It is the system's fault. Nobody can do anything. So that is why I try to take those subjects which has some kind of opportunity apart from industry. Otherwise it will be very difficult for you for the whole of the life, because you need to take promotions also, right?
Yes.
So it's a problem otherwise. I mean, it's a serious problem. You cannot ignore that. So that is why you have to learn topology. That's because you have to clear some exams. That's okay. There are many things you need to learn for clearing exams. That is okay. But choosing subject is a very difficult thing. That's why you have to be extra careful while choosing subject. If
Yes.
you find, go and see that whether computer topology has some application, industry application, not. If it's not, you better not to go. The point is that just do a Google search, you will easily see that whether computer topology has how job opportunity in India, right? So this thing you have to explore by yourself. Otherwise, later on it will be not make sense. I mean, if later on if you explore, it will not make sense, because then you will do PhD, right? So that is
As
the
one, sir, as one PhD scholar I know is Sapna Nayak, whose degree awarded in 2024. They did PhD. in numerical analysis. And later on, many of the research scholars doing their PhD in numerical analysis and some part of the PDE. PDE. So they are, at least they are, I think they are good, but because they have published 2 to 3 papers till now, because the professor always do the seminar and they talk about their number of papers they have published, so we have to clap them. And they tab mm, they are the which are awarded their PhD came university back to cheer up to do PhD and something like this.
See, the point is, that's okay that people are clapping, but the point is that, see, when this kind of thing is happening, that means it is intrinsically people are admitting that getting job is extremely difficult. Okay, that is the first thing. Secondly, is that I don't know what they are doing. I mean, what they are doing, are they postdoc or are they join any kind of industry of what they are doing?
Mm, the last time there are two peoples which completed their PhD and came to the department, and they one of them are mm, teaching some universities, and one of them are in IIT Kharagpur as to postdoc.
So that means there is a at least better opportunity in this new American arts, right? Because at least one of them are teaching, correct? So yeah, it's a problem actually. So you have to choose the subject in a very clever way. And in PhD, 2 papers, you told 2 papers. So let's assume 3 papers, and PhD is very small. At least 4 papers. It's important. That means from the second year itself, you have to run for having papers. That is only possible if you choose the subjects which are not so difficult. Okay, because if you take time for learning a subject, then it is a then your time will go away, right?
Yes, sir.
So that will not work. So you have to run from the second year itself. Then only you can have, you can target 5 papers. You may have 3 or 4 papers then after 5 years. Then only it is easy. Otherwise, it is a problematic situation. Okay. And second thing is that, uh, I mean, see, the point is that uh, debating to do PhD, it's making sense only when people are getting job. If you're not getting job, then there is no point of doing PhD. The job market is, as per my understanding, the job market is almost saturated. Each and every year there are many PhD graduates, and then but each and every year not many faculties got retired, right? So there is no balance. So people, that's why people stay jobless. And then there is something magical term called, uh, so you might have heard the term, 1 minute, called um, visiting position you
Yes,
might
sir.
so that is something called, people are not able to get postdoc, people are not able to get job, but it is a fancy way of, I mean, the point is, some faculty have some kind of fund from the project, and the student faculty agrees to give that money to the student for certain amount of funds. That is called a visiting position. Whenever you say some student visiting position, that means that that student, it is not a student's fault, but that person is unable to get postdoc, unable to get job. Okay, that is the first thing. So this kind of small you have to understand. I mean, the visiting position is a very fancy name, I understand, but this is the reality, that visiting position means, I mean, this thing is applicable for students, not faculties. Faculties visiting position is different. But when a student after PhD, if a student go to visiting position, that means that student unable to get postdoc, unable to get job, unable to do anything. Because after postdoc also, if you are not able to get job, then also you have to go to a visiting position. So that's the thing. Okay, so there is, so don't think like visiting position is something good, bad. There is nothing like that. It means there is, it is not right now, it is not possible to get figure out some job or some post. Okay, and it's a reality. Or do you like applied portion of mathematics?
Yes, sir. Applied portion I like numerical analysis, optimization, and some part of PDs.
then you should explore that, because as per my understanding, my friends, those are PD, all this, there is something called engineering mathematics. There's separate portion of mathematics called engineering mathematics. All these things, they are getting quickly postdoc and quickly job paid. So you should explore that. Okay, I understand those are calculated things, but the point is that at the end of the day, what matters, you have to do that thing, right?
Sir, I'm thinking to go to the optimization part, go through the optimization part because it is more related to the real world application
Yes,
as
yes, yes,
and
yes.
it is also goes through the computational programming way.
Yes, yes. Go ahead. I mean, if that has industrial opportunities, if it has, the point is that it is only making sense if that has industrial opportunities or government opportunities. Okay, government opportunities, for example, okay, for this thing, I don't have idea how government opportunities shall look like. But if these are industrial opportunities, you definitely should think about it serious. Not only that, there are other portions which might have these kind of opportunities. You should also take those things very seriously. But actually, sorry to say, but I prefer not to go in the direction of algebra, topology, tree analysis. I mean, those things which are pure mathematics. Try to have, I mean, don't go that direction. It will be problematic later on. Okay, because if something has no application, why somebody will get money in return, right? So don't go that direction. Go some direction which has some industrial application, real life application, government projects. Then only it will be easy. It will not only easy, it will be enjoyable actually. Otherwise, it will be problematic, right? That's the thing. So your professor may say go to computer analysis, but always remember that I mean always remember a target. Why you need to do PS? That's all. There is no point of gaining knowledge unnecessary. Your target has to be achieved. Otherwise, it's a waste of time. Okay,
Yes.
because here also many PhD students are there. Many of them are pure. Many of them applied. But the situation for pure people are very difficult compared to applied. For applied people, things are not that much difficult. Also, I have applied many job interviews. So I have seen that in most job interviews, 90 to 95% candidates are from pure mathematics. That means what? Most of the applied people already got job generally or postdoc. So this is a difficult situation. It's, I mean, very difficult situation. So try to avoid the pure mathematics in PhD. It will be, otherwise it will be a flat track. Unless and until your guide can give job, your guide can post, otherwise it will be very difficult. Okay, and giving job and somebody, I mean, yeah, that, but that is something which is not your hand, so you have to consider something which is in your hand, right? So that is why do think very carefully, then only you decide it which direction you must. But don't think like, okay, you like this subject, so that's why you want to do PhD. So don't think that way. I mean, I understand that you might not get interested in the subject, but the point is eventually you get interested. That's the thing. So otherwise it will be very difficult, really difficult, because nobody will ask whether you like it or not. People will see how many papers do you have, how many publications do you have. Those publications are in Q1 or Q2. All these things people will see. That's all. Later, nobody will ask how you like or not. I mean, nobody cares. Okay. So that's the thing. Okay, people care. So you go to project. So the project content, you have to do some project in MSc. That is by rule, I guess. Think PhD, you have to think very very carefully. And don't choose guides arbitrarily. You have to talk to your seniors. Yeah, there are a few seniors who are doing postdoc, maybe some of faculty also. Go just talk with them very clearly. Then only you will understand. Also, you have to do Google search by yourself also to figure out these things. Okay. So then only it will be actually useful. At least in India. I'm talking with respect to India. I'm not talking with respect to any other country. So it will not otherwise make sense. In other countries, situation is different. In our country, situation is different. So you have to think accordingly. Okay. So at least for that you have to, anyway you have to practice more and more basic things. Otherwise you have to clear anyway net or gate or any page, right? So
Yes.
clear basic things. For this you have to understand basic, pure basic applied. So read those things. Try to, you are in which semester?
It's a third semester.
Third
Now
semester.
the third semester
Third.
starts.
Hmm. So okay, so do practice problems a lot. I mean, of course, for semester you have to mug up theories. That's okay, no problem. But you have to practice a lot also.
Yes,
Okay.
sir.
By the way, where, I mean, did you choose any guide to whom you are thinking to PhD, or it's not done that wrong?
Mm, I'm not understand. I have to choose now a guide to do a PhD.
No, no, sorry, sorry. Repeat again.
So I have to choose now a guide
No,
to
no,
do a
not, no, no, not,
PhD.
no, no, not now. I just asking that whether you decide something in your mind.
Sir, as the last semester I have taught the things in optimization, so I get the project in complementarity problem, which is so I am thinking to go with this complementarity problem. So I don't know how to find a guide first.
One thing
I
I
have to.
must tell you that, so don't choose any guide who just has joined as a faculty. Okay, so it is one of the important thing you have to remember,
I'm
because
not
they are,
too old to.
no, no, not too, that is also too much old is also, I mean, some faculty who is not a professor but assistant or associate professor, that is fine. But don't choose some faculty who just joined. I mean, don't be first student of any faculty. That's what I'm saying. Okay, don't be the first student.
Okay, sir.
Generally it will be problematic, because there is something which requires experience, right? So
Yes.
don't be first student of inner faculty, otherwise it will be extremely difficult. So that is the thing. So at least choose some faculty who has at least 5 6 years of experience. Then you can join faculty. Then the people has a lot of experience as per my understanding.
Okay, sir.
But as well also, as well as uh, don't choose. Generally, it seems in India it's the same. Don't choose. 1 minute. Hold on.